Thanks everyone for joining. I think we can start. So yeah, as mentioned, Erik will be the one starting. So Erik, the floor is yours. You can start when you want.
Okay, thank you, everyone. Today, I'm going to talk a little bit about how I view FinOps, as in business value-driven FinOps. 2 words about myself. My name is Erik. I'm a FinOps manager currently at the European Commission. I'm a FinOps practitioner and a mentor, and I think I can introduce myself best by my favorite quote, and that is, "You won't win a discussion just because you're right." So that explains FinOps is definitely not a technical problem. First, it's a people problem. So let's dive directly into the topic. Okay. What actually this business value-driven FinOps is. So I guess you sooner or later will have this challenge. Your boss says, have a look at application X and provide some meaningful, deep technical insights to the engineering team. Well, and the issue is obviously that optimizing complex cloud applications obviously is complex and it requires strong technical background. I fortunately have a technical background, but I've discovered a way that even if you don't have access to the engineers or to the architectural artifacts, there's still a way to work around that. So you don't have to basically despair and give up on this challenge. So, but it is a heroic quest. It's not an easy one. So we will together now, in 15 minutes, more or less, conquer the system architecture to provide these deep, meaningful insights without a technical background and without looking at the architecture. So how does it work? We first have to acknowledge a very simple truth, and that is what are actually the cost drivers in the cloud. And that is whenever we store, move, or manipulate any form of data. Okay. That's it. I know it's Captain Obvious, but even if you don't have a technical background, come from finance, come from procurement, you need to realize that data doesn't appear out of thin air. It needs to be moved, it needs to be manipulated, it needs to be stored somewhere. Otherwise, nothing happens in the cloud. Okay. So if we start from that and acknowledge that, then we can actually do something. So how does this actually help us? Because just the fact that we know this now is not enough. No, what we will do is we will check the business requirements, okay? And we will also analyze the performance metrics. But since we don't want to look at the system architecture, what we do is we estimate the theoretical optimum of minimum data transfer that is required and basically bypass the whole problem of looking at the architecture in the first place. So how does this work? Let me start with a practical example. Let's take a small Swedish startup, maybe not so startup anymore. It has a cloud backend. Okay, we know that. It has a mobile app. And if you already guessed it, here it is. I just need a very simple application so that you feel comfortable with the reasoning behind it, and we don't need to think about what the application actually does, because I guess everyone knows what Spotify does. So if we summarize the feature very, very, very grossly, we have the option to search for music, we have the option to play music, we get recommendations because it tracks our songs that we play, and we know it is freemium, right? So you have a free user, we have the premium user. That is something that is public knowledge, okay? And typically you would have, within your own organization, you would have much more information at your disposal coming from the business side, what the business requirements are, what the business value is, okay? So let's start with some obvious stuff, okay? We know you can't fit it all on your cell phone. So there must be some communication going on frequently between the app on your phone and the cloud backend. We know that, that's obvious. Okay. We know there must be some kind of license management to differentiate between free and premium users. And we also know that or we can guess, but it's an obvious guess, that the cloud API must be protected. So we don't have any unregistered access, okay? So what does this say us? Already we can make some assumptions. For example, let's talk about authentication for these protected API. So let's have a use case. If we perform a search 100 times on our phone, how often should we check the user license? If you want, you can also, input your guesses. I don't know if you can see them now, but try to guess how often at maximum or minimum we should check the license of that user if we perform 100 searches. And let me check if I can just quickly see the responses. No, I mean, if we perform 100 times a search, I see, Alexander, your question, within a day, let's say it's within a day. So we have 100 searches, okay? How often should we check for the license, right? Oh, sorry. Let me phrase it this way with another example. Let's say that you send your first email as a FinOps practitioner to another department, okay? They might check with your manager who you are, okay? So that they know that your request is legit. But the next request, they know who you are already. They will have some kind of memory. They will remember who you are. They don't need to check again. So the cloud application we are talking about should do something similar, okay? So if we do 100 searches, it actually should check just the ones when we log in at the beginning what our user license is. So that means if we now check the performance metrics that we have at our disposal without knowing anything about the architecture, we should see per active user, one license check. That is something that we should derive from our performance metrics or logs, okay? If we see that they have 100 or more license checks, that means that it's not effective, it's not efficient. We don't know the architecture. We don't even have access to the architectural documents of Spotify, obviously. But we know already, if we had the performance metrics, we could already say this is not efficient. That would be a red flag and send something to the engineers and say, hey, check your authentication method. Maybe you should cache them. Maybe you should have an authentication token that you can pass on with each request, so you don't have to check the license of the user over and over and over again, okay? So just by checking the business value or the features of the application, actually, okay, we now have, with some performance metrics at our hand, if we had them, could already make a good estimate if this is as efficient or not. Obviously, if you are like 5 or 10% off the optimal, then we won't bother the engineers. But I can now show you with the next case that there are cases out in the wild where you have a factor of several million off the optimum. Okay, so let's say if I now am a free user, I get advertisement every couple of songs. I hate that. I am paying for the premium license. So my expected use experience should be that we immediately stop the ads, right? I don't want to have one more ad in the app, okay? So how often should the system, which is global, okay, propagate this update to the service? Because we can imagine there's more than one service, not just running on one server in a garage somewhere in Stockholm. It's a global application. So they need to propagate this update to the service, okay? It's a leading question, I know. So in that sense, we can already guess we should update this once maybe per server, but that is the absolute maximum we should update. So as I told before, there are applications out in the wild that are far off. So if in the performance metrics, now you check that the propagation of this information somehow is not just once, but millions of times per month. Typically, you would see 2.6 million because that's once per second. That is because some developer maybe thought they go the easy way, right? So if you want to propagate change in the cloud, you can either push changes to any stakeholder that needs to be informed, or all the stakeholders could pull for information once per second. The second one is very simple. It works. So if they have an SLA that these updates need to be transmitted within 1 second, they will fulfill the SLA. It's just simply not the most efficient way to do it. Okay. So in that sense, we would expect from the business description of what the application should do, that we have one update per license change, okay? But if we in the performance metrics find those millions per month, then we obviously have a red flag again. And we can go to the engineer and more or less pinpoint what the problem is without knowing anything about the architecture. Now, I only have 15 minutes at my disposal, and I'm not able to dive very, very deep in every application, but you can see where I'm heading, right? You can basically break this down into smaller topics or smaller parts, smaller scope of the application, and still just check what is the application or the component or the module expected to do from a business perspective. The product manager who wrote the specification of what they should do, what does it say? We can guesstimate how much data or how often the data should be transmitted. And then we go to the performance metrics and identify how often it actually happens in the wild. And we compare that, and that's it. And that was basically my talk. So I'm a little bit short on time, but if you want to connect on LinkedIn, if you aren't already connected, here's my link. You can screenshot that. And yeah, that's it. Thanks for watching.
Thanks, Erik, for this amazing talk. There will be room for questions later on. I think you've addressed some, but I don't know if you have quick comments, and then we can go with Aviv. I don't know the one that with the time frame. I think you addressed that, and then do we know what the typical number of searches per user day? Did you answer that one?
No, I did not. But it's, how can I say, for this kind of exercise, it's not relevant what the typical number of users or searches is if we can divide by the number. So we get the cost per transaction, basically.
Yeah.
So if we know, obviously we need to know that from the performance metrics, but we don't need to know it beforehand. So it's not an information we need to research before starting this analysis or investigation. But it's something obviously we need to know once we compare the performance metrics of what has been consumed in the cloud with how often some service was invoked or called, right?
Okay. Yeah, I think that moving it to the unit level is the most appropriate to understand it. Okay.
And
I don't know.
wait, we have another question from Mendelssohn in the
So-
Q&A.
Yeah. Erik, what would you say for people that are not so technical so they can feel more confident to discuss these kind of things with technical people?
Yeah, I think it's, if you break it down on this level like I just did, we know, you can imagine like it was an SAP application where you design the processes like which department talks, let's say we have a request, okay? Maybe it's done via email, maybe it's done via form, we don't care. So the information must go from point A to point B. We can map that out in our heads or on paper without any technical knowledge how data should be moved or transferred if it was mails, telephone calls, and pen and paper, right? So that we can do the same thing with data that needs to be moved somehow or manipulated in the cloud. Okay, we just check what the business requirements are, and we then compare that with what actually has been moved as amount and frequency of data. So in that sense, I encourage everyone to not let you feel be, how can I say, felt down or looked down upon because you don't have a technical background. but you need to be able to guesstimate this kind of data volume or data frequency, and then basically start a conversation with the engineer who then can say, okay, and maybe you're miles off or you're maybe spot on. But basically, if you can imagine how the minimum optimum is, okay, what is the required minimum to actually achieve the business goal that we have with the application, then you should definitely not be afraid to have such conversation with an engineer.
Yeah.
So in that sense, also one other example that I like to pick is one of the most complex things to optimize in the cloud nowadays are actually Kubernetes, and it's very frequent. We find them in almost every company. But the thing is, even if you don't know anything about how to optimize Kubernetes, it's not right that you simply shy away and say, okay, we don't optimize it. For example, what you can do with it, you can shut it off after office hours if it's not a 24/7 mission critical workload. And if you do that, then you have your typical cost reduction from 168 hours down to 50, and that's 60% something, right? So even if it's complex, you can still consider the things you know about it and make considerations with the knowledge you have. And then you don't have to, how can I say, if you talk to an engineer, they know more about the technical stuff, right? That's normal.
Yeah.
But you shouldn't talk to them as if you knew more. That's not the attitude you should have. You start a conversation because you knew more or have dedicated more time maybe about the cost behind it, or the business needs, the business value and stuff that brings to this conversation. So it's about exchanging information in a collaborative way so that you both can add some insights to this discussion and this conversation. And it's, don't see it as a pissing contest. It's all I'm saying.
Yeah. I totally agree with that, and I think it's perfect for. I see another question, but I think it's we will answer that one at the end of the Q&A, because I think it's a perfect transition to be able to now give the room to Aviv. Now that we talked about the connection between the non-technical people with the technical people, and Kubernetes as an example of a place to optimize. I think what Aviv has to, so yeah, you will get a copy of the recording later on, no worries. What Aviv has to show, it's very related to this topic. So Aviv, whenever you want, the floor is yours.
Sounds good. Thank you, Victor. And thanks, Erik. Yeah, I couldn't agree more, with FinOps folks not having to be shy when they confront and talk to engineers and so on. And I think that's very, very important as FinOps basically, progresses. I'm gonna share my screen.
Okay. Let's stop at the screen sharing from Erik. I think you should be able to screen share now. Yeah.
Yeah, perfect. So maybe a quick introduction about myself, and then quickly about Adaptive6, and then we could dive into the main topic, of today's webinar, which is shadow waste. So pleasure to meet you all. I'm so very, very excited to be in this panel. I'm Aviv Revach. I'm the CEO of Adaptive6. I also recently joined as a governing board member to the FinOps Foundation. And originally I come from a cybersecurity background, and actually our entire leadership in the company, we all come from cybersecurity background, and we actually see a lot of resemblance between the space of cybersecurity and the space of FinOps, where in cybersecurity you sort of have the CISO trying to get everybody to think about security and so on. And in FinOps, you've got the FinOps folks or the CloudOps folks trying to basically get everybody to think about cost. Now, in cybersecurity, it's pretty mature today, right? So it's been there for a while. So there are a lot of very advanced tools, a lot of very advanced methodologies, and in cloud cost, it's just getting started. So this is where we actually see a lot of potential to bring a lot of the methodologies from the world of cybersecurity into the world of cloud cost. And when talking about shadow waste, I think it really resembles a lot of the research work that is being done in cybersecurity and so in other fields and so on. Great. So that's a little bit about me. By the way, some people call me the tallest guy in FinOps. I don't know if it's true, but that's that's my one-liner. So maybe a short introduction, just like 2 minutes about 1 or 2 minutes about Adaptive6, and then we could dive into the topic itself. And feel free to ask any questions, during the session or afterwards during the Q&A. So very quickly, at Adaptive6, we're in the space of cloud cost governance. We primarily serve Fortune 500, Fortune 2000 companies. These are big enterprises. They have very small FinOps team or cloud teams, and they have lots and lots of engineers, and things get out of control. And this is exactly where you really need governance. Our motto typically is, as you might see here in the battle, is don't observe, govern, because I think there are a lot of observability tools out there that help you with financial aspects. But it's really, I think, the next generation of FinOps is all around governance, both of your multi-cloud environment as well as your infrastructure as code. So very briefly, what we do in the company, 4 main things. Number 1, we govern the entire infrastructure, multi-cloud and platform as a service like Databricks, BigQuery, Snowflake, and others. And then we detect more than 100 different types of waste and shadow waste. And when I say shadow waste, this is going to be the topic of today's talk, obviously, and so on. And this is a very comprehensive, list of detections. We are now growing it to more than 500 and so on, and that's really the goal. Number 2, other than finding the issues, we actually help organizations remediate at scale. So it's not just about finding the issues, but exactly connecting to Erik's point, how do we communicate this back to engineers? So we actually close that loop by automatically finding the owner of each one of these issues based on our proprietary technology. It's called Cloud to Code, or based on the tags. And then we automatically communicate issues to engineers through Jira tickets, Slack, Teams, ServiceNow, and so on, giving them all of the context they need, while we also handle exceptions, follow-ups, escalations, and so on. The third aspect of our platform is essentially fixes with AI. So we are the only platform out there that really leverages AI to this extent of actually fixing infrastructure as code, and basically providing and empowering engineers with the right, not just the right context, but with the right code fixes. And then with one click, they could basically push this back to their Git as part of their standard development process. And the fourth and last piece of what we do is that we don't just focus on the waste and shadow waste you have in the cloud and how to remediate that, but actually how do you shift left and prevent it from the get-go. So we actually embed cost efficiency into the pipeline. So you could basically say from now on, for instance, no more GP2, right? And you could enforce those kind of policies. So that's very, very briefly about Adaptive6. Moving on. So moving on to today's topic, what my personal goal for today's discussion, it's all about shadow waste. I think that for a long time, the FinOps community, myself included, we all talked about, waste, right, which is a big thing in the industry and so on. And I think I see more and more organizations now asking, okay, what's next, right? What's next beyond the the standard things that we typically see with the cloud service providers, with tools like Azure Advisor or AWS Trusted Advisor, or with some of the observability tools of the world and so on. And this is where shadow waste kicks in. But right before we discuss shadow waste, maybe we should start by defining what waste is, right? So this is the official definition by the FinOps Foundation talking about waste, which is any usage or cost of resources which provide no value to an organization, right? And you guys know the stats the same as I do. And common types of waste that you guys are very familiar with, I will be certain, are unused resources, over provisioned VMs that require right sizing, storage buckets that don't have proper archiving or intelligent tiering, and these kind of things and so on. This is the standard waste that we basically, as a community, we all talk a lot about these days and so on. What I want to present next is the definition of shadow waste, and then we're going to dive into very concrete examples. My personal goal today is basically for you to basically have the ability to take these home, very actionable insights, and back to the office and basically check these type of things in your organization to make it worthwhile for you. So when we talk about shadow waste, and this is just the definition that we have for it in the company, it's basically the following. Shadow waste refers to hidden or overlooked inefficiencies that basically evade the standard cost management practices, just like I mentioned. typically due to the fact that you have some complexity in the infrastructure or lack of visibility and so on. But I think other than the definition, I think the best way to describe it or to think about it is through examples. So I tried to list here a few examples of different types of shadow waste that basically fall under that definition. So one is complex service configurations. You have a lot of services across the multi-cloud environment. In some cases, it's easy to configure the service. In other cases, it's very complex. We're going to see some examples to that later on with DynamoDB and others, where it gets very, very tricky for a FinOps person to basically look at it and decide what to do and so on, and we're going to see that. Another type is service configurations that are advanced. In some cases, people are well aware of the typical things you could do in terms of configuration, but there are some hidden or advanced capabilities that people don't typically think about. So we're going to touch on that. Another type of shadow waste is architectural inefficiencies. So these are not just, things that you basically fix with a standard configuration. This might require a little bit more effort on the engineering side, but the gains could be very, very significant, right? So that's another category. The fourth one is applicative setup and configuration. So when we think as a community about shadow waste and about waste in general, we typically stay in the scope of the infrastructure itself. When I'm talking right here about applicative waste or applicative setup and configuration, this is actually within the workload itself. So these are not the typical things when people think about waste that people typically think about. This goes a further step. Other examples, and I will just run over these quickly so we could get into the actual examples. Niche services that people are using within the different clouds. In some cases, different types of platform as a service like Databricks that a lot of folks use and don't have a good way to basically find shadow waste over there. Many times you have production and dev environments that look pretty much the same, and that basically creates a lot of shadow waste, and we're going to talk about that. And you can see some of the other examples and so on. Let's dive into concrete examples. Essentially, I've got 6 examples to share with you today, and then we do like a quick recap afterwards, and then some time for questions. So, number one. This basically talks about the nature of some of the service configurations being very complex, right? So in this case, let's talk about AWS, but we're going to have examples for all clouds and so on. So in AWS, obviously you've got DynamoDB database. DynamoDB has basically 2 modes, 2 throughput capacity modes: on demand and provision. This is one of the areas where it gets very, very tricky, and we've basically seen a lot of customers basically, get these confused and so on, where the way that AWS charges really depends, on the mode that you choose, and choosing the right mode could also get very, very tricky. So when you look at on-demand capacity, if you choose that option to basically just pay on demand for DynamoDB, you could see right here the way it's charged, around 12.5 cents per 1 million read request units. This means request to the DynamoDB for read. And this is just example for read. You could do the math for write as well. When you do provisioned capacity, however, it's built in an entirely different way, and you could see how much it's cost per hour, and this is per what they call provisioned read capacity, right? So this means read request unit per second, just one of them, and then it gets built over an hour. As you can see, this could get very, very complicated in terms of understanding what exactly does each and every one of your DynamoDBs require. So if we take a quick example, if you have 100,000 read requests per second to your DynamoDB table, basically if we look at the different numbers right here, on-demand capacity will bill you at $45 an hour. Provisioned capacity you would basically get billed at $13 an hour, right? So in this case, you should probably be going for the provisioned capacity. The difference is quite massive, as you can see. It could save you a lot of money. There are other cases where it actually makes more sense to do on demand and the other way around, especially let's say if you have a workload where it's only open, DynamoDB that basically only gets 30 minutes a day of read request, and that's it, right? And the entire day is basically idle. Then you might want to actually use on demand. So these things could get tricky, and this is exactly where you have a lot of hidden shadow waste that people don't typically think about, because it's rather complicated to do some of this math and so on. Some word of some note I want to mention. It's really important when you do this exercise to continuously do it over time. You know, it's not like a one-time thing. This could have high gains, but it would require some time and effort from your end. And also, if you do choose provision mode, just bear in mind that basically leave some buffers, right? When you do it, don't just do, you know, the exact minimum and so on, because after you basically pass the limits that you place on provision mode, you could actually get in trouble with throttling and so on. So these buffers are really important. And if you have any questions about that, feel free to send me an email after the session. I would share my email afterwards and so on. So this is my first example, and I hope it clarifies you know, this type of waste, which is around complex service configurations. Moving on to the second one. So essentially, this basically talks about applicative waste, right? Applicative setup and configuration. When people typically think about cloud costs, they don't typically think about the workload, about the application. Now, this really amazes me, because at the end of the day, if you look, for instance, at Python versions of workloads before version 3.13 could actually be up to 20% less efficient and more costly compared to this version of Python. Now, important to stress, this is not because of end of life. Like some folks, they're thinking, let's upgrade to the latest version because of end of life. This is not the case. This here is because they made a remarkable change, both in Python 3.12 and 3.13, that actually introduced a lot of new capabilities and optimizations to it that made it far more efficient. And most folks, and also many engineers, basically are unaware of that. And this could be a very, you know, like rather quick win if you have a lot of Python workloads and so on. And if you want to, and actually it could actually become even easier if you're using serverless functions like Lambdas, Azure functions, Cloud Run functions on GCP, then basically if you look at the metrics, you wouldn't see any problem. But if you look at the configuration, you could actually change that configuration. And obviously you need to test this with your workload and making sure it works properly. But at the same time, the gains, the potential gains could be remarkable. Now, this doesn't just exist for Python. This is also for Java and Spark and various other types of applications and so on. This is just one example, just, you know, the tip of the iceberg, just to get, you know, everybody to start thinking about these things that are costing a lot of money. And I think this is our journey as a FinOps community is going to this type of shadow waste. My third example is around production and dev, right? So essentially, you basically have production. Typically, you mirror to the same environment, you know, in dev and so on. You pretty much keep it, you know, very similar. In some cases, some folks, they're doing right sizing in dev that is different from the right sizing they do in production, which is very, very good, because they think they understand that they don't have to be completely identical unless you're running some load testing tests and so on. But they don't necessarily think about the fact that you could have not just smaller VMs, but actually different configurations, right? And in this case, this is what we see out there in the wild with a lot of our customers, where basically you see a lot of unnecessary high cost without justification. And this is just a partial list. So in this case, you see in non-production, you see folks having databases with multi-AZ, right? Doesn't make sense, or high availability mode and so on in the other clouds. DynamoDB, global tables, right? Basically giving you, you know, basically more regions that you serve from and so on. DynamoDB Accelerator, that's another example. This would give you additional performance. It's worthwhile when you are in production. Maybe you don't need it when you're in a dev environment, right? And then you have a couple of more examples right here. Basically just you know, stressing the point that production and dev don't need to necessarily be identical. There is a lot of waste that exists, shadow waste that exists within dev environments, and you just have to start looking for it and so on. And these are just a couple of examples. Moving on to the next example, I believe. So right here we're talking about a different type of shadow waste. In this case, this is architectural inefficiency, right? So it's not just a configuration aspect, and it's not in the application as we saw. This is within the service, right? Within the service, the service architecture that you basically have. So in many cases, what you typically see is the diagram down below. You basically see that folks are using NAT gateways in order to allow EC2s to basically that basically are placed in private subnets to access S3. What really happens behind the scenes is that when you have this setup, the EC2 would basically go all the way to the web, to the internet, and basically all the way to the S3 bucket and so on. This is very wasteful, and there are basically better ways to do it, right? And this is one of these areas of shadow waste that when you set up when engineers set up the system at the very beginning, this might really make sense. But over time, you actually have a lot to gain by actually changing the architecture to move to VPC endpoints, right? VPC endpoints basically is a capability, in this case by AWS, that basically helps you to dramatically reduce the cost, because then the access from the EC2 to the S3 doesn't go throughout the internet, right? So this saves a lot of cost and so on. So this is a good example of how, somewhat a small change into the architecture would basically save a lot of money. Of course, it requires a conversation with the relevant engineers and so on, but it really is a low-hanging fruit in that regards. Then I think I have two more, examples for this session, and then we'll basically do a recap, and then we can discuss how do you actually identify more of these and so on, not just the examples that I gave here. So this is really, I think this is the fifth example. So this talks about, you've got services. We all know, pretty much the standard way of configuring them, but then you have advanced configurations that people don't necessarily think about on a day-to-day basis. One of those, in this example, an Azure example, is ephemeral OS disks. So what happens is that if you have workloads that are stateless, and by stateless, I mean they don't necessarily need to basically have their state kept on an ongoing basis. For instance, most of the web servers, you could actually switch from a standard, in an Azure VM, from a standard storage into ephemeral OS disks. What this does is that instead of using the standard, storage that Azure provides, this would actually use the VM's local disk, and basically would save you cost, because using the local disk would not incur any cost, right? This is just free of charge and so on, included with the price of the VM. This is a really good saving opportunity, right? For shadow waste and so on. You do have to bear in mind, this is just for stateless workloads, right? So when you have these conversations with the engineers that you work with, make sure to understand whether it's a stateless workload. Typically, web servers are a good candidate for that, and you might be able to switch to ephemeral, and you could save a lot of money by doing that. I think this is this is my last example. So right here, I'm talking about a different type, which is niche services, right? So we talked about configuration of existing services, some advanced configurations. What about some services that are not the common ones we all talk about? We all talk about, the EC2s and the VMs in Azure and other clouds and so on. We all talk about databases. What about the other ones? Whether it's within the multi-cloud or whether it's within platform as a service, right? So for instance, if we take Databricks as an example, you don't typically have a lot of ways to see, the waste and what's going on within Databricks. So this is just, a very low-hanging fruit example. And Erik mentioned, shutting off servers. So this connects. Basically, when you look at Databricks, you have a way, basically, when you use interactive clusters in Databricks, you have a configuration for auto-termination for these clusters. So essentially, all you need to do is just activate this configuration, and this is it. Otherwise, these interactive clusters will just stay live for a long period of time, and this could be extremely costly. And most folks, they are just not necessarily aware, and it's really, really hard also to keep track, right? And I know of every single service that the cloud providers offer, every single service and configuration that that you have for Databricks and these kind of services and so on. So this is a good example. There are more. Be on the lookout and look for them and so on. So a quick recap of all of these examples, and then I'll dive into the last slide, which is going to talk about how do you find more of these, right? So what have we seen, right? So we're talking about what shadow waste is, and then I covered a few examples. Number one, complex service configurations, right? So you have, in this example, DynamoDB, throughput capacity. How do you choose? Very complicated to do this configuration, a lot of potential gain. Another example of shadow waste, applicative setup. You go inside the application, inside the workload. You don't just stay in the infrastructure. This is the next frontier for us as FinOps folks within the community. The third example is production and dev mirroring, not just keeping the exact same unless you really have to, right? If you need to do it for performance, do that. But in many environments, you don't need to keep the same level of performance. Look for these things, whether it's multi-AZ, whether it's DynamoDB accelerator, whether it's other types of what I showed before in the previous slides. The fourth example is architecture inefficiency, where you could make some changes, sometimes small, sometimes slightly bigger. In this case, not a big one. Switching from between NAT gateways and VPC endpoints. The next one is service configurations that are rather advanced that people don't typically think about, like Azure Ephemeral OS this. And the last one is niche services, whether it's within the cloud, people are using SageMaker and so on, and don't really get to think about what are the possible ways to optimize it, or whether it's within the platform as a service like Databricks, Snowflake, BigQuery, and others. We also talked about some other types of shadow waste. I don't have time today to cover them, maybe in a follow-up discussion, but I hope that this gives everybody sort of an understanding of what shadow waste is, concrete examples that you could basically start looking for inside your infrastructure. Many folks basically that I talk to, they say, okay, we already got the obvious things covered. What's next? So this is it, right? And then my last slide right here is, how do you actually find shadow waste, right? Like other than these examples. So I think, first of all, and this is how to do, you need to get a little bit more into the technical aspects of each cloud and each service. It could be very hard. I would advise you to look at your top 10 resources, not just the top 5, and start, basically starting to read about these things more specifically. Number 2 is to start and look for the best practices and the pitfalls and so on. I think that the FinOps Foundation is doing a great job at accumulating a lot of this information. There is a lot of information out there. And then I think another thing that I think we all as FinOps folks really need to adopt more and more, and the community is talking about it, is AI. I think that AI is your best friend when you're talking about shadow waste, because I saw the questions that you guys raised to Erik about not necessarily knowing all of the bits and bytes for the engineers, but I think at the same time, with AI, if you provide to an AI, to an LLM, basically the list of your top 10 highest spending resources and so on, and ask for best practice recommendations, you could gain a lot, right? Just by doing that. If you could add more context to it, like telling him about your specific workloads, even better, right? Always bear in mind that you need to check the official documentation. That goes without saying, because we know about hallucinations of LLMs. But at the same time, this is a great source of information. I truly advise you, to be doing that. And of course, there are other, places like these type of webinars where you could have access to this type of information. The third point here is basically trying to look for resources that don't conform, that basically are not aligned with these best practices after you found these best practices. And the fourth point, as you could see, is essentially asking yourself these 4 questions. Why is it configured this way? Maybe there is a good reason, right? Is there an alternative cloud service that is better to do what I'm trying to do? Maybe there is a chance that this was configured a long time ago. This happens a lot out there in the wild from what we get to see. A lot of folks made a decision to do something a long time ago, maybe a year or 2 ago, and then 2 years later, the situation has completely shifted. And then am I paying for some aspects I don't really need? Because some of these configurations, they might not lead to high expenses and others are. So I know this is sort of a methodology that we are basically using, and I advise you guys to use also as basically looking into shadow waste and so on. So this is it. We're going to have a Q&A shortly, but I do want to share, this is a QR code, and basically you could see my email right here. If you have any questions, anything you would like to ask or just consult, really feel free to hit me up, and I would love to, to find some time and chat with you.
I think it was a wonderful presentation, Aviv. It was super, super interesting and full of value. So everyone is asking about the slides, so we will be able to provide those after the call. So we will send it on the follow-up email of this webinar to all the registrants. We will be able to share with you all the content. So now on, we start with the question and answers. I see some raising hands, but I'm going to start with the questions in the take time order. So I think this one was from the topic of Erik. And it says from Mausam, due to the improper tags and labeling, it is difficult to find the resources attached to specific applications and their owner. Also, FinOps practitioner having less privileges to check the insight in the cloud, how to overcome this challenge, where you can get the application insight from the for the cost optimization perspective. Erik?
Ooh, well, it's a tough one. Yeah, it's why FinOps was also created, like to overcome these problems. But the thing is, I think there's several things you need to do here. One is implement some control policies for tagging. Okay, work on that. For example, you could first make some how can I say, some report that says how high your tagging coverage is. Okay, and also find out how much of your cost is not possible to allocate at the moment to the correct cost center, budget, team, whatever. Okay, and get some executive buy-in to do something about it. Okay, because with that you can simply also say, let's make it that you cannot launch anything if it's not properly tagged. That's a very simple thing to do on most clouds. If it's not tagged, you simply cannot run it. So done. Okay, so that's solved. Obviously, you need to discuss it, implement it gradually, maybe also start with the non-production environments, because otherwise, if you have a pipeline to start production stuff and it doesn't start because the tag is missing or misspelled, you will not make friends. But if you go gradually there and prepare basically the teams and tagging, and also one other thing is there are some tools that provide virtual tags that you basically say that any form of misspelling, maybe you converge into one tag. I would say that's a nice feature to have, but it's sugarcoating the problem. So you should not, in my opinion, go that way. Really go clean up the tags, implement them, enforce them through policies, and then you're good to go. Then the second part of your question, the FinOps practitioner having less privilege to check the inside in cloud. I'm not exactly sure what you mean by that, but the thing is, if you need information, get it. As in, if you need a tool, buy it. If you need more access rights to see, I don't know, the workloads like Kubernetes get access into the memory consumption stuff, get it. It's something that you simply should say, okay, I don't have the information now. Any kind of piece of missing information, transform that into a task that you need to work on, liaise with people, and get the access rights there. Okay, that is the only way to overcome this challenge, actually. Because otherwise, what you do is you give yourself an excuse to not do something about it because you don't have all the information. And that's it. So basically, make a list of everything you need, and every missing item there is a task for you to go through. Talk to your manager, boss, whatever, and that's it. There's no nice way around this.
Yeah, I completely agree. Thanks for the thoughtful answer, Erik. So next one was Alexander asking about how would you recommend calculating waste fund for KPI reports. I think this is super interesting. I don't know if Aviv, do you have thoughts on that one?
Yeah, so I think that's like the $1 million question, right? How do you calculate waste in terms of KPIs? I think the first step is that you really need to know about that waste, right? So I think you need to have some system in place, if you build it internally or use some third party and so on, to basically govern all of that waste. And then after you have that in mind, because at the end of the day, if you're only looking at the 20 things that basically the cloud native providers provide you, this is very, very basic. So it's not a good measure of for a KPI. But when you actually look at the entire scope, or like a big scope of waste and shadow waste, then you could actually give an efficiency score based on that, right? And then you could actually compare it between the different departments and so on. So I think the number one thing is first to identify all sources of waste, or the most common ones, including shadow waste, and only then you could switch to talking about the real KPIs. You could do something in between. You could start looking at all of the recommendations that you currently have with the cloud native or whatever tools you're using, and then create an efficiency score. My only point there is that this would be very behind, because it wouldn't be the clear understanding of the efficiency, because it lacks a lot of shadow waste that we just discussed and so on.
Okay. Yeah, it's the $1 million question for sure. Like relating to KPIs is what every business wants. So yeah, great answer, and great question, Alexander. Next one, well, it's a kind of a question like, this is a big deal. Who is looking at versions of Python by Erik? I think that's a super interesting point that Aviv raised regarding the Python optimization capabilities based on the version. It's a super simple thing to do, yet many of us, and I include myself, don't necessarily do it. So really a good advice from Aviv on that regard. And I think the next one in order was Aaron, in terms of asking. So I will enable you now the microphone. So Aaron, whenever you have the raised hands, I don't know if you want to ask. If not, we can go with the next one.
It was an errant hand, but glad to catch the kind of second part of the conversation, and I appreciate you guys all sharing your insights.
Okay. Thanks, Aaron. Thanks. Really appreciate the kind words. Okay, so moving on to the next one, Nilofar. Thanks for being here, Nilofar. I'm going to try and summarize because it's a bit long. So basically, she asks about that it is crucial to understand the business rationale behind each decision as well. Not of all of them would necessarily translate into actionable items. So additionally, addressing these issues would require both time and resources, which ultimately at cost. Human resources are a cost that everyone should have in mind. In situations like this, how would you approach balancing the need to optimize costs with the business priorities driving these architectural choices? This is super interesting question.
Yeah.
So what you need to do there is the following. Apply some product management. So whether it's a feature that needs to be developed, or whether it's a optimization of any kind, we know, as you also stated in your question, that there will be resources consumed for this. So you should be able to calculate the cost of implementing it, which also should include the opportunity cost of leaving other stuff behind. Okay, so obviously, if you have one engineering team, you cannot do the work of two engineering teams just because you add something. Okay, so we need to schedule that. So in that sense, you should calculate the business value of the cost reduction, or the performance efficiency increase, whatever it is, and align it strategically with the basically the company strategy. Okay, so if the company strategy is to ship features fast and quick, okay, because they want to conquer the market, they want to ship new features, or they have customers waiting, SLAs and commitments, then obviously this needs to go into your consideration. Because what you otherwise can do is the following. Let's say that your company is more software oriented and has sprints regularly. I don't know, it's like 6 sprints per year, 4 sprints per year, or big sprints, okay, not small sprints, but or let's call them development cycles. Okay, so it's more generic. So it's oftentimes difficult to get a slot for optimization in these development cycles. So what a friend of mine did at Spotify actually was they took the least, how can I say, loaded development cycle, which was the one in January, I think, and said, you know what, let's take that, no features development in January. We only look at optimizing efficiency every January for the large thing, re-architecting, making A/B tests with high load and stuff like that. So basically they got cost optimization development cycle each year, which was much easier to sell to the execs because then they know, okay, no new features in January, but that's fine. We know that already. So they plan out and the marketing also in that way. Because otherwise what you risk is that you have a feature and it's too big, will explode any kind of feature planning with the development teams, or you have small items that never get enough priority. So we'll just swap over into the next development cycle and never gain enough priority. So I think these are the two that you need to do. You need to provide the business value of the cost optimization, including the opportunity costs, and maybe also have an optimization development cycle per year or something.
I just want to add one more thing. If I add, I completely agree with you, Eric. I want to add that I think that what we try to do, with customers we see is actually also reducing the friction and the time it takes engineers to actually handle these issues. Because at the end of the day, cost is not a big priority for folks, right? Like you said, like it's basically features. They care about performance. They care about reliability and so on. And security and cost is down below. So I think many times when we try to go through the path of product and so on, this is good maybe for bigger things. But I think for other things, it's very worthwhile to see how you could actually minimize the time it takes an engineer to investigate and fix an issue. So when a FinOps person comes to an engineer and tells him vaguely, there might be an issue here, then that takes a long time. An engineer it would basically take them 1 or 2 days to investigate and fix, and then they keep postponing it. They would never do it, right? Because they have higher priorities. Our philosophy is that if you actually lower down, you basically reduce the time by giving them very actionable insight. This is exactly just like in today's lecture. This is exactly what we see in whatever, DynamoDB, right? These are the metrics. This is the evidence. This is actually what you need to do. It's just like one click in DynamoDB to switch from that to that and so on. Of course, you need to test it, but this is it and so on. I think as you make it more, as FinOps people need to take more responsibility when they deliver and communicate this to the engineer to make it very, very lean. So then this would enable engineers to do it like nuggets. They would just do them, right? Because it doesn't take 1 or 2 days to do something. It takes 1 to 2 hours to investigate and fix an issue. So I think that's also what you described is part of the the strategic way to approach it, and I completely agree. I think at the same time we need to think as a community, how do we actually minimize the time it takes an engineer? So these things would just be things that people do regardless of just the sprints and so on. This is the situation I think we should aim as a community, just basically making it easier for folks.
Totally agree on that one. And I think there is an additional question for Aviv. How can you show the value of Adaptive6 is different from an optimization recommendation such as AWS Cost Optimization Hub or any of the native, let's say, offering by the cloud providers?
Oh yeah, sure thing. So I think the cloud providers are doing a great job and so on. But one, they do it just for their clouds. Adaptive6 is multi-cloud. And second of all, this is our claim to fame. We focus on shadow waste. We find more than 100 different types of waste and shadow waste across the various clouds, across platform as a service. And we're actually growing this to 500. So I think it's very easy to see side by side. If you want, you could email me afterwards. But it's very easy to see side by side when you test any tool in the industry, not just the cloud native providers, and you compare it to Adaptive6. I think it would be very easy to see the potential ways that we discover. Some of the examples I gave today, these are just the tip of the iceberg of what we typically detect, and we haven't seen too many tools in the industry that really do these type of things. And you mentioned before, the Python is just one example, and there are many more. So if you want, you can hit me up later at avivre@adaptive6.com, and I would love to share more.
Yeah, yeah. You can reach out. I also wrote the email on the chat, but you will have it on the call recording as well, and on the presentation it would be available. And there is a last one from Mausam again. Thanks for being so active on the questions, everyone. Really appreciate it. So that's a question as well as a point of view which I am facing right now. We have some good opportunity to right size the dev environment, and the architects are not agreeing. Business takes their advice more seriously, and this is a big roadblocker in FinOps as of now in my organization. So any, let's say, solutions or ideas to Mausam, Aviv, or Erik?
Yeah, I would say get some business value of that, as in how much money are we talking about? Because if it's $50 per month and the architect says they're needing it, then maybe the ROI of your optimization isn't even that high. But if we are talking about, I don't know, 50K per month difference, okay, and they don't simply agree, then they should state the business value, because you said it was a development environment, okay? So ask them to provide their business value of having such an expensive resource and compare it with the business value of optimizing that downside. Obviously, you need to back that up with some usage and performance metrics, so you can show that resource has been more or less idling or sleeping, and then say, hey, we can save this much money. What is your business case for keeping it on 24/7 at this cost? So that's it. Ask them for numbers to justify using the resource at that level.
Right. I want to add to that essentially I think that engineers, they care somewhat about cost, but what they really care about many times is efficiency. Right. So
Yeah.
I think when you talk the lingo of engineers and you talk about underutilization and so on and less efficiency, I think that could also help in that regard. And I think this relates to also my earlier point, evidence. Right? If you provide evidence and you basically show them, right? This is what you basically are doing. This is the last 2 years. This is the P95 or the max or the average, and they just get to see it. I think this would, together with what Erik mentioned, which is what the business value is, right? This should basically get them to feel somewhat uncomfortable by knowing that this actually exists and so on. I don't know the exact nature of their, the friction point with you talking to them. There are various points, but I think what Erik touched and what I'm touching is 2 of the or 3 of the main points that typically we hear from engineers.
Yeah, I mean, so engineers are focusing on efficiency. If you relate it more and you try to ease the way to the architects, and you make it easier, and also you relate it to performance and more efficiency and easiest management, especially, which can happen, for example, on serverless instead of Kubernetes or whatever. Any suggestions of that matter would probably help you sell, let's call it that way, the case to engineers, which sometimes are tough to deal with.
By the way, the example with the Python is a clear case of additional efficiency. It would basically be more efficient, the workload, and you have a cost benefit. So when you have these cases, right sizing is another example. When you have these cases and so on, it's good.
Indeed, totally agree. Okay, let me see if there are more. Okay, not one. Last one in the extra time. Can you suggest easier ways to view or export metrics from someone without the scripting, coding knowledge, like API, CLI, Python SQL query, etc.? I believe, and before everyone answers, on the dashboard tooling, there are definitely some, exporting metrics tool on CSV. Normally, CSV is a format that is available in everywhere. And from there, you can work on Excel, or you can work from whatever. In terms of viewing, almost every provider has a viewing system where you can relate log metrics, or specifically anything that you want to measure. The only problem that you probably need is, or you will probably have, is to configure the actual metric, and being able to having the skill to actually know where each of those are. because there are a lot of them and you can configure almost anything. But with log metrics, I think you can have almost anything related to compute, storage, memory, etc. You can almost do anything with already a native tool, even though, you know, other providers have it. Aviv, any inputs on that one?
No, I think you summed it up perfectly.
Thanks. Let me see if there are more. I think that's all. Yeah, finalize, and this is done as well. So yeah, thanks everyone for joining today. It's been a pleasure to have you all here. Thanks Erik for the talk, and thanks Aviv of course for the talk. It's been a pleasure. Thanks everyone for joining. I hope you had a good time. Tomorrow we'll send you the recording and the slides. See you next time. We will be doing this frequently. So heads up and stay tuned in LinkedIn and the newsletter because we will do more of this. Thanks everyone. And yeah, see you in the next one.
Thank
Bye,
you.
guys. Thank you. Bye.
Bye.